Okay, welcome to Scientific Notation Part 2. So please watch these videos in a series. So if you wherever you see a Part 1 or Part 2, or you see a group of lessons, Scientific Notation, I know there's Scientific Notation Part 1, 2, and 3, but there's also operations with Scientific Notation and another lesson or two dealing with Scientific Notation. So please watch all 5 or 6 videos. Again, if you have never watched the welcome video, please watch that and take a look at the intro to numbers and operations, and that will give you a good understanding on how this channel works. So saying all that, let's get off into the first lesson. Okay, here's our objective. Vocabulary. Here's a picture for you. I'm going to start putting pictures in some of these. Some basic rules and notes. So our first example, this number, let me put the pin on. This number is smaller than 1. And so we know that whatever we have is going to be times 10 to the negative whatever. So let's look at what we got to do. So we have to move the decimal 1, 2, 3 spots to make it between 1.0 and 9.9. And now all we have to do is count. We move the decimal 1, 2, 3 spots. And that's how you convert a decimal into scientific notation. Okay, write this in scientific notation. Well, 7 million. 7 million is 7 with 1, 2, 3, 4, 5, 6 zeros behind it. Okay, so let's now write it in scientific notation. So 7 million, I'm going to put a decimal point at the end of it. 1, 2, 3, 4, 5, 6. So 7 times 10 to the 6th power tells us that we have this exponent is positive, even though it's not written as positive, and that tells us that we have a number that is bigger than 1. So 7 million is bigger than 1, is 7 times 10 to the 6th power. Okay, example 3, write in standard form. So that means going from scientific notation, this tells you how many times to move it, and if there's no sign, it's positive, and we know we're going right 12 times. So 1.4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And put zeros in the humps. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Zeros gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 3, 3. Millions, billions. So 1.4 trillion. That's what 1.4 trillion. So that's a lot of money. So when you hear them talk about budgets and they talk about trillions, that's what it looks like. Okay, compare which one is bigger. 6.3 times 10 to the 6th or 6.4 times 10 to the 4th. Well, this number, the base, is not really all of that important. What's important is the exponent. So if I take 6.3 and I'm on the decimal 1, 2, 3, 4, 5, 6 times, put my zeros in. Oops, I moved 7 times. Let me erase the last one. I knew something didn't look right. So that becomes 6, 3, 1, 2, 3, 4, 5, 6.3 million. And now looking at 6.456, we move 1, 2, 3, 4 times. And now you ask yourself, what would you rather have? $6.3 million, or $6,300,000, or $64,560. So this number is bigger. So the exponent is most important. Well, if the exponent is the same, then you would look at the numbers, the base numbers themselves. Okay, so order these numbers from least to greatest. So now all we have to do here is just look at our exponent. And 10 to the fifth is the smallest, so I'm just going to put 935 times 10 to the fifth. And I'm not even going to worry about anything else as a base. So now 6 and 6 are the same exponent, so we're in the same place value. 8.17 is bigger than 7.07, so 7.07 times 10 to the 6 comes next. And then finally 8.17 times 10 to the 6 is the largest number that we have. And those are our examples. So I will meet you at the end of this video for the recap. Okay, problem one, in scientific notation, the decimal goes at the end of the number because there's no decimal written, and we just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 57 billion. 5.765 times 10 to the 10th power. 3, 6, 9, 10. Yeah, 10 to the 10th. Okay, write in standard form. So this negative means that the decimal goes left and this number is going to be less than 1. So 3, 5, 1, 2, 3, 4, 5, 6, 7. Put zeros in the hump. And then we have 6 zeros. So our number is 1, 2, 3, 4, 5, 6, 35. And that's our answer. Okay, which one is bigger? -5, -5. Now be careful when you're dealing with numbers. So what I'm going to do is I'm going to actually write this out. So 7.23 goes 1, 2, 3, 4, 5. 1, 2, 3, 4. And 9.5. 1, 2, 3, 4, 5. 2, 3, 4. So 0.000095 and 0.00000723. Well, 95 is bigger. So they have the same. Well, what you could have did to make a shortcut was the same base, or the same 10 power of 10 to the negative 5. I'm sorry, the base is different, but the exponent is the same, and we know that 9.5 is bigger. Okay, so problem 4, go from least to greatest. So what's the smallest? -9 is the smallest, -6 is second, and -5 is the largest number. So be careful when dealing with your negatives. A larger negative is actually smaller, because you have to think about it like this. Would you rather owe somebody $5 or $9? And I think we would all want to owe somebody $5 as opposed to $9. And 17 times 10 to the -9. Okay, so that is from greatest to least. And be careful how they want you to order it. So the instructions become very important. So thank you for watching this second video in a series of 3 that are related, and then 2 others that are related as well. So please watch all videos in this series. And if you like what you see, subscribe and hit that notification button for more videos to come.